Objectives for the lesson are to explain why elements in the same group have similar properties, use electron configurations to identify the 4 blocks in the periodic table, and finally identify the period and group based on the electron configuration. Keywords for this lesson are as follows: periodic table, period, group, valence electrons, and electron configuration. I'm hoping you're familiar with all of those words and you've come across them in some form previously. Classification of elements, part 1. Valence electrons. Now this was discussed in the previous topic when we were looking at electron configurations. So valence electrons are the electrons that are located in the highest principal energy level. And if I take my example that I've written there of sodium, I've written the electron configuration of 1s2, 2s2, 2p6 and 3s1. Now I've highlighted 3s1 because 3 is the highest principal energy level in sodium. So every electron that's located in principal energy level 3 would be classed as a valence electron. Now in this case we only have one electron in that s orbital, so we only have one valence electron. And argon is another example, so I've written out the electron configuration again of 1s2, 2s2, 2p6, 3s2, 3p6. Again, my highest principal energy level is energy level 3. So every electron contained within energy level 3 is classed as a valence electron. I have 2 in the s orbital, I have 6 in the p. We add them together, we get 8 electrons in total. Therefore, argon has 8 valence electrons. And I've just shown you there in the diagram, that's the electron dot structure that we've looked at previously. And for argon, there are 8 electrons if you count them around the outside. Now groups, this is linked very strongly to the valence electrons, and groups on the periodic table are each individual column. So if you follow my cursor here, group 1 is this group here that goes down in this column, group 2, group 3, I'll move over here to group 13, 14, 15, 16, 17 and 18. Now we're going to focus on groups 1, 2 and then 13 to 18. We're going to actually leave out this section during this lesson. Okay, this section here is called the transition metals in the middle. Now the group number tells us the number of valence electrons. So everything in group 1 must have 1 valence electron. Everything in group 2 has 2 valence electrons. If we scoot over to group 13 here, well, it doesn't have 13 valence electrons, but it has 3 valence electrons, okay? So everything in group 13 has 3 valence electrons, group 14 will have 4 valence electrons, 15, 5 valence electrons, 16, 6 valence electrons, 17 will have 7 valence electrons, and 18 will have 8 valence electrons. So this rule applies only for those groups that I've just spoken about, which is groups 1, 2, 13, 14, 15, 16, 17 and 18. Periods. So if we look on our periodic table again, the period is the horizontal row. So here is period 1, which only contains hydrogen and helium. If I move down to period 2, we have lithium, beryllium, boron, carbon, and so on. Period 3, across there, period 4, 5, 6 and 7. Okay, now the period number tells us which principal energy level the valence electrons are in. So if I'm in period 1, we know that the valence electrons are in energy level 1. If I go to period 2, the valence electrons must be in principal energy level 2. If I go to period 3, they must be in principal energy level 3, and so on. So if I take sodium as my example again, we said the principal energy level, the highest energy level, was 3. Okay, and if I look where sodium is, well, it's in period 3. Okay, because that valence electron is located in the 3rd principal energy level. Okay, moving on then to classifying the elements. We've spoken about periods, we've spoken about groups. What we can do is use that electron configuration to locate the element on the periodic table. Now argon, electron configuration of 1s2, 2s2, 2p6, 3s2 and 3p6. What we can see is that the valence electrons are located in principal energy level 3. Now what that should say straight away is if it's in principal energy level 3, it must be in period 3. And then to find out what group we are looking at, then we count the valence electrons in principal energy level 3. We have 2 plus 6, we have 8 in total. Therefore, 8 valence electrons is linked to group 18. Remember, we said we're not looking at any of those groups between group 3 and group 12. So group 18 is linked to 8 valence electrons. Little question for you to have a go at. Can you work out which period and which group magnesium is in? And I'm telling you it contains 12 electrons. So you're going to need to write an electron configuration, and then you're going to need to work out the period and group it's located in. Just pause the video whilst you work that out, and I'll discuss the answer shortly. Okay, magnesium, you should have written out the electron configuration to be 1s2, 2s2, 2p6 and 3s2. As I've highlighted here, the valence electrons are located in the third principal energy level, and if we count up the valence electrons we only have 2. Therefore, the third principal energy level where the valence electrons are located tells us it's in period 3. The 2 valence electrons tells us it's in group 2. Thank you for listening to the presentation. There will be a second part to this lesson.